Hello, Year 4, and welcome to Friday's science lesson. So, what are the two ways we learned yesterday that we can change the volume of sound? So, yesterday we looked at the volume of sound and how it can be changed. So, who can remember the two ways? The first way is the strength of the vibration. So, you might remember yesterday I had a pan and I was saying, which got with me today, the weaker the vibration, the quieter the sound, the stronger the vibration, the louder the sound. My poor ear. The other way we can change the volume of sound is distance from the source of the sound. If we stand close to the source of the sound, the noise is louder because the vibrations are stronger. If we stand further away from the sound waves have less energy because they have to travel further, so they become weaker and quieter. Now, today I want you to be thinking, are there any other ways we can change sound? We said yesterday we know we can change sound through volume. Is there any other ways? If you think about sounds you can hear, how can we distinguish differences between them? How can they change? How can they sound different? And one way is through pitch. And I'm not talking about a football pitch here or a sporting pitch. This is to do with sound. So the word pitch is part of the sound and musical vocabulary. Okay, so pitch is when sound is either low or high. So a sound can be different. It can sound different to us by having a low pitch or a high pitch. For example, a lion's roar is at a low pitch. The sound is low. Whereas a bird tweeting is a high-pitched sound. It has a higher pitch. So the pitches are different, whether it is a low sound or a high sound. And today we're going to be learning about why sounds have different pitches, why some are low, how some are high, and how we can change this. So, for example, excuse me, if we try and sing a low note or sing a high note or speak in a low note and speak in a high note, we can change our voice. So, for example, some people have higher pitched voices. Hello. Some have low voices. Hello. They are pitches. Low is down low. Hello. You can try it. Try and say it as low as you can. And then you can also have it for a high pitch sound. You try it for high as you can go. Okay, so maybe a scream is quite a high-pitched sound. So sounds have different pitches, whether they are low-pitched or high-pitched sounds. And this depends on the shape and the frequency of the sound waves. So this all depends on the vibrations and the sound waves created. High-pitched sounds have different sound waves than low-pitched sounds, and that is why they sound different. Some are high and some are low. We're going to watch a little video that should help you. So let me share my screen with you. Okay.
Sounds can be high-pitched, like the squeak of a mouse, or low-pitched, like the roar of a lion. But what is it that makes these vibrations different? This explorer is wearing special goggles. They let him see sounds in the air all around him. The sounds he sees are like waves. Some of them are tight, squiggly waves, like this. A drum with a very tight skin makes this sort of wave. It's what we call a high-pitched wave.
So a high-pitched wave has a tight sound wave.
And some of the waves are long, loose, rolling waves, like this. A drum with a loose skin makes this sort of wave. It's what we call a low-pitched wave. Excuse me. I think maybe you need to take the glasses off. You're about to walk in. Oh, too late.
Okay, so from that video, we learned that sound waves differ and they create high and low pitched sounds. Now, we learned that high pitched sounds, like a bird tweeting, have a high frequency. So this means they vibrate faster and they are short, tight sound waves. So because they're so short and tight, they vibrate faster and it makes a high pitched sound. So you can see here the sound waves are short and tight and they're really close together. And because they're so short and tight, it makes a high-pitched sound and they're vibrating faster. So high-pitched sounds vibrate faster. Can you think of anything that is high-pitched? Can you think of something? We've got birds tweeting. You might think of a mouse squeaking. You might know someone who has quite a high-pitched voice. You might think of a singer that has a high-pitched voice. You might think of a creature that makes a high-pitched noise. Okay. And low-pitched sounds have the opposite. Instead of a high frequency, they have a low frequency. They vibrate slower and they have long, loose sound waves. So you can see here, these sound waves are far apart. They are long and loose. This creates a low-pitched sound because the sound waves are traveling that bit further. They're going through the air and they are long and loose. So short and tight is high and long and loose is low. So you can remember long and loose for low, short and tight to high, long and loose for low. So they're very slow as well. If you're long and loose, the sound vibrations are slower. Can you think of anything with the low sounds? We've got a lion. Can you think of anything else? Maybe you can let me know tomorrow on our live lesson, well, on Monday for our live lesson. But I have got a little clip here where we can listen to some high and some low pitched sounds. So let's hope this comes through on the computer. Okay, so here are some high-pitched sounds, and they're made through fast vibration. So like we said, they are small and tight, and they create high-pitched sounds. So for example, a violin can create quite high-pitched sounds when the strings are tight. High-pitched sound. So a violin can make quite a high-pitched sound. You might hear that in some musical songs where they've got tight, high-pitched sound, and that is because the sound waves are tight and short and they're vibrating quickly. Now, slow vibrations create low-pitched sounds. They are long and loose and slow. For example, the engine of a car or a truck makes a low-pitched sound like this. So the sound waves there are long and loose, and they create low-pitched sounds, okay? Just like a lion's roar, and just like a bird's tweeting creates high-pitched sounds. So here I've got a drum. Now, we know, as we've seen with Mrs. Southwood's lesson on Monday, this is the skin of a drum. Now, if I have a drum with a really, really tight skin, what pitch will the sound be? So let's think. The skin will be tight. If it's tight, it means the vibrations will happen faster. So, fast, tight. That must be a high-pitched sound because the sound waves are close together, they are short and tight, and they are vibrating faster. So a drum or a guitar with tight strings, tight skin, that will create a high-pitched sound because the sound waves will be tighter, they will be shorter, and it will vibrate faster. What about then if I loosen the skin on my drum? What will happen to the sound the drum makes? What will happen to the sound? So it was tight, it was fast, but now I'm loosening it, which means that the vibrations will be slower, it will be looser, and it will be longer. What will happen? The pitch will become lower. If we loosen an instrument like a drum, the skin on a drum, the strings of a guitar, the strings of a violin, we will create a lower pitch, And that is because the vibrations will be slow, which means the sound waves will be long and loose, which means the pitch will be lower. Okay? So, here I've got a child in my class's instrument. They created this, which I was so impressed with, at home last week. And you can see here they've put some strings around a butter tub, which creates kind of like a guitar. Okay, now, if I got this child's instrument and I tightened the strings by putting a knot at the end, so I put a little knot down here, I tightened it up, I tightened up the strings, what will happen to the pitch of that instrument? What will happen to the sound it creates? Will the pitch become higher or will the pitch become lower? So let's think. I'm tightening it, which means the vibrations will be faster, which means the sound waves will be shorter and tighter. Try and think which is short and tight. And you should have said higher. The pitch will be higher. This is because the strings are tighter, making them vibrate faster, producing a higher pitch. Okay, they're tight together, it makes a high pitched sound. Whereas we know long and loose means slow and low. Okay, now I've got another instrument, a bottle of water. So if you have a bottle of water with some liquid in it and you blow across the top, we know it creates a sound, as you saw in Mrs. Southwood's lesson again. So if I put more water in my bottle, here's my bottle, and I put more water in it, so I turn it into this bottle, I'm putting more water in, will the sound be of a higher pitch or a lower pitch? So let's think. Putting more in, there'll be less room for vibration, which will mean they will vibrate faster. What will happen if they're vibrating faster? Okay, so we should have said a higher pitch. By adding more water, we're giving the sound waves less space to vibrate. They don't have as much air to vibrate in because most of it is water now. There's less air. So because there is less air for them to vibrate in, they're vibrating faster and faster, which creates a higher pitched sound. Because remember, if the vibrations are faster, if they are tighter, it makes a sound. If the vibrations are long and loose and slow, it makes a low sound. And you can think of that because if you've got long L, loose L, it makes a low sound which starts with an L. And also, slow rhymes with low. Long, loose, and slow, low. High, tight, and short. Okay, is for high. So long, loose, and slow, low. You can remember that rhyme when you're doing your work. It'll help you. Now, I'm very excited for your activity today. You've got 2 tasks. Activity 1. You've got some questions about pitch. And for this part, we need to really slow down. Remember that rhyme. Long, loose, and slow, low. Tight, short, and fast, high. Long, loose, and slow, tight, loose, tight, fast, and short, high. Okay, so you've got your questions here. Think of something, animal, an instrument, a creature, that makes a high-pitched noise. Which pitch has a long, loose sound waves? Is it high or low? And which pitch is created by fast vibrations? Is it high or low? Then your task 2. So I want you to take your instrument and change the pitch of the sound. Okay, so you can do this by what we've shown, tighten or loosen the strings. So I know some people in my class have created around a coat hanger, they've got some string around a coat hanger, you might tighten that up. If you've done what the child did with the butter tub, you might put a knot inside the elastic band or the string and you'll tighten it up. If you have created something that you can shake, maybe you've got a bottle with water in, or a jar with marbles, or a bottle with rice, and you're shaking it, you can either fill it up more, or you can pour some objects out. What happens when you fill it up more and you create less space for vibrations? or when you pull some of the object out, you create more space vibrations. So I want you to tell me what you did. So in the first sentence, you might say, I tightened the strings on my instrument. I put a knot in the elastic bands on my instrument. I put some more rice inside the bottle. I took some rice out of the bottle. Tell me what you did. And then what did you notice? So play your instrument before, change it, play your instrument again. What has happened to the pitch? Has the pitch got higher? Has the pitch got lower? Now, it'd be really impressive if you can explain why. So if you can say, I note the pitch got higher because of da 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 da. Tell me about the sound waves. Okay? Remember, long, loose, and slow, low. Tight, short, fast, high. Okay, and then we've got the differentiated task. Saying you've got one question at the top, think of something to make a high pitched noise, and you are doing the same, you're finishing my sentence. So I've color coded it for you. The tighter, the more loose, the fuller or the emptier, the your noun, so what is your instrument? Is it a string that you tightened, elastic band? Did you put more in the cup or the bottle? The higher or the lower the pitch. So you need to complete this, look at the colours carefully, and then write your sentence in the yellow box. We need to write it out fully in the box with capital letter and a full stop, please. Okay, in the box at the bottom. So that is what you're doing today. I'm very excited to see how you change the pitch of your instrument, the sound that is created from your instrument. Again, if you want to film this and send a video to Mrs. Southwood or I, we'll be very impressed. I always love seeing your instruments and what you can do at home. Obviously, I would love to see it if we were in class, but we can't right now. So make sure you do your work, send it across to us, and have fun. And we'll see you soon. Have a lovely weekend, and I'll see you on Monday. Bye.